In the realm of Azure Compute Solutions, function triggers play a pivotal role. They are the mechanisms that initiate the execution of Azure functions. Understanding how to implement these triggers using data operations, timers, and webhooks is crucial for developing efficient and responsive applications. This presentation will delve into the various aspects of function triggers, providing a comprehensive guide on how to leverage them effectively in your Azure solutions. Azure Functions is a serverless compute service that enables you to run event-driven code without having to explicitly provision or manage infrastructure. It supports a variety of programming languages and can be triggered by various events, making it a versatile tool for developers. The core concept is to write the code that responds to events, and Azure takes care of the rest, scaling as needed to meet demand. Function triggers are specific events that cause an Azure function to run. These triggers can come from a variety of sources, such as HTTP requests, messages in a queue, changes in a database, or scheduled times. Each trigger type is designed to handle a specific kind of event, allowing developers to create highly responsive and efficient applications. Understanding the different types of triggers and their use cases is essential for effective Azure Function implementation. Data operations triggers are used to initiate functions based on changes in data. For example, a trigger can be set to run a function whenever a new item is added to a storage account or a database. This is particularly useful for applications that need to process data in real time or near real time. Common data operation triggers include Azure Blob Storage triggers, Azure Queue Storage triggers, and Cosmos DB triggers. Blob storage triggers are activated when a new blob is created or an existing blob is updated in an Azure storage account. This type of trigger is ideal for scenarios where you need to process or analyze files as they are uploaded. For instance, you could use a blob storage trigger to automatically resize images, process log files, or extract data from uploaded documents. Queue storage triggers are used to initiate functions based on messages in an Azure Queue Storage. This is useful for decoupling application components and ensuring reliable message delivery. For example, you could use a queue storage trigger to process orders in an e-commerce application, where each order is represented as a message in the queue. The function would then handle the order processing logic. Cosmos DB triggers are activated by changes in an Azure Cosmos DB database. This allows you to respond to data modifications in real time. For example, you could use a Cosmos DB trigger to update a search index whenever a new document is added to the database, ensuring that your search functionality is always up to date. This type of trigger is particularly useful for applications that require immediate data consistency. Timer triggers are used to run functions on a predefined schedule. This is useful for tasks that need to be performed at regular intervals, such as data cleanup, report generation, or sending out periodic notifications. Timer triggers are defined using a cron expression, which allows for flexible scheduling options. For example, you could set a timer trigger to run a function every day at midnight to generate daily reports. Cron expressions are used to define the schedule for timer triggers. They consist of 5 fields representing the minute, hour, day of the month, and day of the week. For example, the expression 00** would run a function every day at midnight. Understanding how to construct cron expressions is essential for effectively using timer triggers in your Azure functions. Webhooks are a way for applications to communicate with each other in real time. They are triggered by specific events, such as a new commit in a GitHub repository or a new form submission. In Azure Functions, webhooks can be used to initiate functions based on these external events. This is particularly useful for integrating with third-party services and automating workflows based on real-time data. To implement a webhook trigger, you need to create an HTTP-triggered Azure function that listens for incoming HTTP requests. The function can then process the request data and perform the necessary actions. For example, you could create a webhook-triggered function that listens for new commits in a GitHub repository and automatically deploys the updated code to a staging environment. This allows for seamless integration and automation of development workflows. When implementing function triggers, it's important to consider security. Ensure that your functions are protected from unauthorized access by using authentication and authorization mechanisms. For HTTP-triggered functions, you can use API keys or OAuth tokens to secure access. Additionally, consider using Azure Key Vault to manage sensitive information such as connection strings and API keys. Implementing proper security measures helps protect your application and data from potential threats. Monitoring and logging are crucial for maintaining the health and performance of your Azure functions. Azure provides built-in monitoring and logging capabilities through Application Insights and Azure Monitor. These tools allow you to track function execution, monitor performance metrics, and diagnose issues. Setting up proper monitoring and logging helps ensure that your functions are running smoothly and allows you to quickly identify and resolve any problems that arise. One of the key benefits of Azure Functions is their ability to scale automatically based on demand. This means that your functions can handle varying workloads without requiring manual intervention. Azure Functions can scale out to multiple instances to handle high traffic and scale back down when demand decreases. Understanding how scaling works and configuring it appropriately ensures that your application remains responsive and cost-effective. To get the most out of function triggers, it's important to follow best practices. This includes designing functions to be idempotent, meaning they can be run multiple times without causing unintended side effects. Additionally, ensure that your functions are stateless, as this allows them to scale more effectively. Use dependency injection to manage dependencies and keep your functions modular and maintainable. Following these best practices helps create robust and efficient Azure functions. Let's explore a real-world application of function triggers. Imagine an e-commerce platform that uses Azure Functions to handle order processing. When a new order is placed, a queue storage trigger initiates a function to process the order. A blob storage trigger then processes the order's invoice, and a timer trigger sends out daily sales reports. This setup ensures that the platform can handle high volumes of orders efficiently and provides timely updates to stakeholders. In conclusion, implementing function triggers using data operations, timers, and webhooks is a powerful way to create responsive and efficient Azure compute solutions. By understanding the different types of triggers and their use cases, you can design applications that are both scalable and maintainable. As you continue to develop your Azure skills, consider exploring advanced topics such as durable functions and integrating with other Azure services. The knowledge gained from this presentation will serve as a strong foundation for your journey in Azure development.